Oh, welcome and thank you for joining. In this lesson, we'll review some algebra skills from grade 9. Our focus will be on simplifying polynomial expressions and solving equations. Remember that to simplify polynomial expressions, we need to group like terms. And like terms will have the exact same variables raised to exact same exponents. In the first example, we have a polynomial expression. And as you can see in here, we have a second degree term, first degree term, a constant term, first degree term, a constant term, and a second degree term. And the only variable that is present throughout the polynomial expression is x. So step number 1 would be to collect like terms. So first, let's identify them together. Whenever I identify the like terms, I start off from the very first one, start in order. So as you can see, we have x squared in here, and then you visit every term in a polynomial expression to see if there is any other term that contains x squared. So in our case, we have x squared and 3x squared that are like terms. And then we have 5x and negative 2x that are like terms, and negative 7 and positive 4 that are also like terms of the constants. So we'll continue by grouping the like terms, which means that we're going to write them next to each other. So we have x squared plus 3x squared, and then plus 5x minus 2x minus 7, and then plus 4. So now that we have the like terms close to each other, we can simplify more easily. Remember that when we add or subtract like terms, the variable part will stay the same, which means that that will still remain an x squared term. And whenever you don't see a number before x squared, it means that the coefficient of it is 1. If it makes it easier for you, then you can write a fake 1 in here, and now you know that we're adding numbers 1 and 3. So we have 1x squared and 3x squared that together will make 4x squared. So next we have 5x, which is subtracting 2x. So again, similar idea or same idea, we should say. So we are subtracting just the coefficient. So 5 minus 2 equals positive 3, and then x. And lastly, we have negative 7 plus 4. Negative 7 plus 4 is negative 3. And this would be the simplified form of the polynomial expression. Now, keep in mind that the final form must be, or the terms in the final answer must be listed from highest to lowest degree. So you can try the next question on your own. I'm going to work on it quietly. Like terms. And then lastly, the constants. So we have 2y squared minus 6y squared plus 12y minus 8y plus 9 plus 7. So what that means then is that we have these two will go together, and then we have these two terms go together, and lastly these two together. 2y squared minus 6y squared is negative 4y squared. 12y minus 8y is positive 4y, and 9 plus 7 is 16. So in the next example, we will multiply polynomial expressions. And for this, we'll have to use what we call the distributive property. So multiplying expressions or expanding expressions means the same thing. So we are expanding and simplifying 3x with x minus 4. Remember, 3x is what we call a monomial, one term, and x minus 4 contains two terms that are separated by a minus, or it could have been a plus, and we call this a binomial. Now, since we're multiplying 3x by this binomial, it means that every term in the binomial will be multiplied by 3x. So 3x will multiply x. Let's write this down. And then 3x will multiply negative 4. Simplify. Remember that when we multiply two terms, we have to multiply the coefficients together, the variables together. So when you have 3x, it means 3 times x times, and here we don't have a coefficient, which means it is 1x. So in this case then, and I'm going to write this in expanded form. I know you know this, but just want to make sure that we understand what's going on here. So 3 times x, which will give 3x to the power of 2. So in multiplication, we have to add the powers. So when you see no exponent, it means exponent is 1. So you add the 2 exponents, and you make 3x to the power of 2 here. Next, we have 3x times negative 4, which is basically 3 times negative 4 times x. 3 times negative 4 is negative 12 times x. There is nothing that we can simplify. The terms are from highest to lowest degree, which means that we have simplified the expression. You can try the next one on your own, and then follow the solutions afterwards. So again, identify the monomial first. So we have 2a, that is multiplying a squared, negative 2a times a squared, and then negative 2a multiplies negative 6a, and then negative 2a again multiplies 1. Negative 2a times a squared, remember the power here is 1 because we don't see it. In multiplication, we add the powers, which means we're adding numbers 1 and 2 together. So 2a to the power of 3 negative. Here we have negative 2a multiplying negative 6a. Remember how multiplication works. The order doesn't matter, which means we multiply negative 2 with negative 6, and that will give a positive 12. And a will multiply a, which gives a squared. And lastly, we have negative 2a times 1, which is negative 2a. And this is completely simplified. Terms are from highest to lowest degree, and that means we're done. Next, we are expanding expressions that contain more multiplications, more than one multiplication. So to simplify an expression, we have to remove the brackets and collect like terms. So in this case, we have to first examine the expression. So you have a bunch of polynomials multiplied, and this one here on its own, a minus in between. So we are multiplying 3 by x minus 2 and then subtracting x minus 4. So number 3 is multiplying only x and 2 because it is a factor, we say, or it's a term on a monomial before these brackets only. So that means we have 3x plus 6. Now you have a minus. When you have a minus means that you have minus 1. So if you want to see it as a coefficient of negative 1 times x, negative 1 times negative 4. So that's negative x plus 4. Now we have to group like terms. 3x and negative x, positive 6, positive 4. So 3x minus x plus 6 plus 4 is 2x plus 10. This is the final answer. Now try the next one. 5 times t, 5 times 4. 5t plus 20. Negative 3 times t, negative 3 times negative 1. Negative 3t plus 3. Be very careful with the signs. So two minuses will multiply to a plus. A minus with a plus multiply to a minus. It's a common mistake and very easy to make. So 5t minus 3t, like terms, plus 20 plus 3, like terms. 5t minus 3t equals 2t plus 23. So in the next exercise, we're evaluating a polynomial expression. To evaluate a polynomial expression, we substitute the value of each variable by the numerical value and then evaluate by using the order of operations or BEDMAS. So let's take a look at our exercise. So we have 4x squared minus 3y. So the idea is that 4 is multiplying x squared in here and then minus 3 multiplied by y. So the value of x is 2. The value of y is negative 3. So wherever we see x, then we'll substitute it with number 2. And wherever you see y, you replace it with negative 3. So we have 4 multiplying, we see x in here, that means that's a 2 to the power of 2. And then minus 3 multiplying, there is y multiplied by negative 3. So remember, we have to follow BEDMAS. So brackets first, but as you can see here in brackets, inside brackets, there is only a single number, so there is nothing we can do. Even if we had brackets in here, you can write this in this form, it means the same thing. So with brackets, 2 to the power 2 or without, there is nothing to do inside the bracket. So you have to do the exponents. So first we have to bring 2 to the power of 2. So we have 4 times 2 to the power 2, 4. And then negative 3 times negative 3, that's a positive 9. So you can go straight ahead and multiply because they're not connected to this. So then we have 16 plus 9, the answer 25. Try the next one. So this time we have x equals 2, we have y equal to negative 3, and we have z equal to positive 5. So wherever we see x, we replace it with 2. Wherever we see y, we replace it with negative 3. And wherever we see z, we replace it with positive 5. Again, don't forget the order of operations. So let's get started. So x is 2. It's multiplying y, which is negative 3, to the power of 2. Now be very careful here. We have to keep negative 3 in brackets and bring to the power of 2, because when the base is negative, so the value of the exponential number can be either positive or negative. So the safest way to do this is by keeping the base in brackets. And then we have minus, z is 5. It's multiplying x to the power of 2. X is 2 to the power of 2. You can keep it in brackets, doesn't really matter. And plus y is negative 3, multiplying z, which is 5. So again, we have to follow the order of operations, which means that we have to apply the exponent first. Like there is nothing to simplify inside each set of brackets. And we have 2 multiplying negative 3 squared. Remember, negative 3 squared will be positive 9. Minus 5 times 2 squared, that's a 4. Negative 3 and 5 multiplied to negative 15. So we have 18 minus 20 minus 15. So that would be equal to negative 17. And voila, this would be the answer. Next, we'll take a look at solving linear equations. Now, to solve an equation means to isolate the variable. So the way we have done this with linear equations is by transferring all the terms, variable terms, to one side and the numbers to the other. We simplify each side and then we isolate the variable. So let's take a look at our first example. We have 2x minus 3 equals 11. X is our variable. That's what we want to isolate. We don't have any other x terms, which means that the term 2x will sit on its own on the left side. Now, the number negative 3, remember, we call it transfer it to the other side. That's the operation. But the idea is we're adding 3 to both sides of the equation to maintain the balance, but also to get rid of the constant here on the left side. So 2x sits on its own. And that will give 11 plus 3. So when we say transfer the term to the other side, it's a shortcut for adding the same number to both sides. So we have 2x equals 14 And now remember, we want to isolate x. What are we isolating x from? Number 2. What is the operation between x and 2? Multiplication. So how do you isolate the variable from something multiplying it? You do the reverse operation, which would be division. So we have to divide 2x by 2 to get x on its own. And we have to do it to both sides of the equation, which means that x is equal to 7. This would be the solution. And with this, we're going to say that we have solved the equation. Now, you may be wondering, how about making sure that this equation, this solution is correct? How do we do this? Well, in order to check if our answer is correct, then we can perform a formal check of the solution. To check means to prove that the right and the left side of the equation have the same value. So the way we do this is by substituting the value of the variables or the solution into both sides of the equation and simplify them separately. So let's do this together. So the way I like to do this is by making a t-chart. So on one side of the t-chart, the left side, I will write the left side of the equation, which is 2x minus 3. And on the right side, we have number 11. Now remember, this is a very simple equation, and sometimes it can be a lot more complicated than this. So we are substituting x on the left side, and x is equal to 7. So that means we have 2 times 7 minus 3. On the right side, in this particular equation, we have nothing that we want to replace it with. So that's 14 minus 3, or 11. So the left side equals 11. And as you can see here, the right side is also 11, which means that left and right are equal, which means the solution is correct. Now let's try the next equation. 4 plus 2x minus 3x equals minus 3x minus 16, negative 3x minus 16. So x is the variable here. And it appears on both sides of the equation. So we're going to keep 2x on the left. We're going to take 3x on the left on the other side, which means the minus will turn into a plus. And then we have negative 16 is already on the right side, so we don't change that. But 14 is coming from left to right, so number 4, is going to the other side, so it becomes negative. 2x and 3x simplify to 5x equals negative 20. Now we're isolating x from number 5, which is multiplying x in this case. And that means that we have to divide by 5 both sides, and then we have x equals negative 4. That's the solution. If you want to check the answer, again, we perform a formal check. We write the left side, which is 4 plus 2x, and the right side, which is negative 3x minus 16. X is negative 4, so 4 plus 2 times negative 4. That would be 4 minus 8, or negative 4. Let's check the right side. We have negative 3 times negative 4 minus 16. Negative 3 times negative 4, positive 12 minus 16, that's negative 4. That means that x equals negative 4 made the left side equal to the right side. And it's a coincidence that the solution actually equals the value of each side as well. Now we're going to take a look at one more equation. This time we are working with equations that involve fractions. So whenever you have equations with fractions, first step is find the lowest common denominator. As you can see here, this has a denominator 3. This term here has denominator 5. They have no common factors, and that means that the lowest common denominator will be exactly the product of the two denominators of 15. So now we're going to take the left side of the equation, and we're going to write here x minus 1 over 3 and 2x minus 3 over 5, that's the right side, and we'll multiply both sides of the equation, or each term, by 15. And look at the little miracle that we witnessed here. Sorry, here we go, 15. We'll divide 3 to give 5. And 5 now multiplies x minus 1. Now here, 15 divides 5 to give 3. So 3 will multiply 2x minus 3. So you see now we have an equation that is free of denominators. All we have to do is start solving. So 5 times x, 5x. 5 times negative 1, negative 5. Now, don't forget to multiply 5 by both x and negative 1. A common mistake we tend to make is we multiply by the first term and we forget to do the second one. So the second one must be multiplied by the number in front of the brackets. Okay, next we have 3 times 2x and 3 times negative 3. So that means we have 6x minus 9. Now, take the variables to the left, numbers to the right. So whichever term is being transferred to the other side, we'll switch the sign. So 6x here became negative because it moved. Well, it didn't move, we moved it. And negative 5 became positive because we took it to the other side. So 5 minus 6 is negative 1x, negative 9 plus 5 is negative 4. Now see that x has a coefficient here. The coefficient is negative 1, so that means we're not done yet. So we have to divide both sides by negative 1. And voila, we got our answer, x equals 4. Let's try one more. So we have x plus 1 over 8 plus x plus 3 over 5 is equal to 3. And you have a fraction here, and this is not a fraction, but we have to make it into a fraction. And any number can be a fraction with denominator 1. And now that we know we have fraction everywhere, we have to find the lowest common denominator of all the denominators we see. So see that 8 and 5 don't have any common factors. So the lowest common denominator will be the product of 8 and 5. So that's a 40. So again, same strategy. The first term, x plus 1 over 8, will be multiplied by 40. The second term, x plus 3 over 5, multiplied by 40. The last term, which is 3, multiplied by 40. So let's shoot the denominators now. 40 divided by 8 equals 5. 40 divided by 5 equals 8. 40 divided by 3 over 1, basically 40, right? So that doesn't change. So now we rewrite the equation with no denominator. So we have number 5 will multiply x plus 1. Now, number 8 will multiply x plus 3. And number 40 will multiply number 3. Let's see what we got here. 5 times x, 5 times 1. That's 5x plus 5. 8 times x and 8 times 3. Well, that's 8x plus 24. 40 times 3, 120. Group like terms. On the left side, we have 5x and 8x and 5 and 24. So we simplify each side of the equation. So 5x plus 8x is 13x. 5 plus 24 is 29. Together, and these are together. The other side, 120. Let's continue here. 13x is the only variable term, sits on the left. 120 minus 29. So 13x equals 120 minus 29, it's like 91. So that will make x equal to 91 divided by 13. X equals 7, and that's the end of it. Please practice your homework questions. And before you start doing your homework, read the questions, the solutions that are the notes that you took in class, because that gives you a better idea of how to answer all the questions. If you ever get stuck, just go back to your notes and check and see if your question, your practice question, resembles any of the questions we discussed in class, and try to take it from there. Okay? So reflect on your learning whenever possible. Think of the things that you've learned and try to articulate them the way that you understood them, the way you saw them. And if you ever have any questions, come back to class well prepared with a list of questions. Thank you for learning with me, and bye for now.